Our primary interest is in trying to better understand how productivity in the overlying waters, where there's lots of light, might fuel nutrient demands of the productivity in the lower light regions of the ocean. Ocean gyres they're so large. They're the most expansive ocean habitats on the planet. And they're basically these systems of circulating currents rotating within each major ocean basin. And so because of their size, ocean gyres account for about 20% of the ocean's productivity. And they have some very characteristic and unique features, one of which is persistently low concentrations of nutrients in the surface ocean.
In the desert, we mainly see that there's aloes and these plants that are able to persist without a lot of water. In the ocean, it's the same. We see that there's these organisms that are really adapted to low nutrient environments. I mean, they're teeny tiny and they're able to just persist, ready for when nutrients become available to them.
Simply put, we are examining nutrient flow between ecosystems. We are going to a series of research stations that are on what we refer to as the low nutrient subtropical gyre.
So when we are trying to understand the ecology of the open ocean from satellite observations, we are only seeing a thin layer of phytoplankton at the ocean surface, like observing a vast grassland from above. We understood a lot of the dynamics that take place in this surface layer, but we don't know much about what happens in the ecosystem that is below.
In the surface ocean, we have these microscopic plants called phytoplankton that use the nutrients in the surface as they grow. And then once they die, they start to sink. So unlike in the forest where you have leaves that are on the tree and then only when they get to the ground do they decompose, in the ocean this process can happen continuously.
As particles are settling downward and they're being decomposed, nutrients could be fueling the subsurface layer of the upper ocean in ways that we've never thought about. And so really a goal of this project is to help us better understand what drives the decomposition of those particles, or what changes how fast they undergo decomposition. To what extent are the nutrients that are recycled from that decomposition used before they leave the upper ocean? One of the essential nutrients cycled by phytoplankton is carbon, and therefore the SUBSEA project is at a critical point in Earth's trajectory because of the rapid increase in carbon dioxide. So the more we can understand how the oceans participate in moving carbon dioxide from the atmosphere into biology, the more we'll understand how the planet is functioning under a high CO2 condition.
For every second breath you take, one of them you can thank the ocean because of photosynthesis by phytoplankton.